Hello, everyone.
Oh,
All right, welcome to ITS 454. Today is our last day. It's the last day of the semester. So congratulations, you survived 454 online. All right, so we are done today. We are doing our final presentations today. I'll do some final announcements. And then, and then that's it. We're done for the semester. So I remind you that we have our exam on Tuesday. It'll be a written exam, comprehensive, okay, online. So you can expect that. I think we did an online exam already for the midterm, so you know the format basically.
yeah.
So that's going to be Tuesday at the designated time by the university. Today, we're just wrapping up our presentation. So we did a lot of the presentations on Tuesday. Today, we're wrapping up those. And then that's about it. I think you need to submit your project files. I've already created the Dropbox. It should be in the project folder. I also will be posting the ABET surveys online, so look for those by tomorrow. And I believe that is it. So if you have any questions, please go ahead and ask. Otherwise, I can see that there's a couple of groups that want to start presenting. So Shashing's group will present first. Then second group will be Alex, Gutierrez, and Parker and Brandon. And then Trevor Portinga and his group will go after it. It's group 3. So if you want, just, if you're presenting today, just write it on the chat. I'm looking at it right now, and that should give me an idea of the schedule for. Are there any questions before we get started? All right, seems like there's no questions. Okay, so then I guess Shashing's group and whoever else is in that, please go ahead, share your screen, and you may begin. Just remember, give me time to write your names and also kind of explain, what you're doing. Thanks.
Okay. In our group, 心理夏精神文亮成
I'm sorry, Singli. Did you say something?
心理
Yeah, Singli, yeah.
夏精神
Shashing, hold on. Okay.
文亮成
Wenliang.
Yeah.
Okay. I got him. So, all right, guys. So what are you presenting today?
VPN encryption.
Your VPN. Okay. All right, please go ahead.
Okay. First, we want to share our configuration at the client. We can see the we do not have the gateway on the client. We do not have the gateway on the client, so if we don't have the tunnel 0, it is impossible to make VPN client to access host V, and then we can see the routing table to see how we configure the tunnel 0. We put the TLS server at host V. Can you see the host V? I'm sorry, I share my screen again. Okay. In the host we put the TLS server in the host we. Can you see this one? This. Then we running the command as a host we. And come back to the client. Okay, you can see on the host we the SSL connection established in the client. We can see the successful information in the client, and then we open the Wireshark. We can see the information. First, the client will send client hello message to the server. When a client tries to establish a TLS connection with the server, it first sends a TLS hello message to the server, and then once the server receives the hello message, it will send back a message to inform the client about the client's decision. And then the server will send its public key certificate to the client. And then the server hello done. Next, the server will send the client will send client key, and after that, the client will send a change server spec message to the server, telling the server that the communication from client to server will be authenticated and encrypted. And the client sends the finish message. Finally, this process is finished. We can see the corrupted alert. And this is the configuration and results part. Let's move on the coding part. That's my partner Xiaxing to talk about the code.
So first, we begin from the client. Can you scroll? Or can I share my screen? Okay. Okay. Can you hear me?
Yes, we can hear you.
Yes,
Okay.
yes, we can hear you.
So we start from the server side. This is the code of our group. So first we can see begin from the main function. And this is this two lines for the initialization and for the error message. The initialization can register the available ciphers and digests. And the error messages, error strings can help to print out some error strings. And at here is SSL context initialization. So this means it will create a TLS handshake and initialize it by creating an SSL context data structure. And this too is about the verification for the public key and the private key. So, and then go down. So from here, it's begin about the socket programming, and we can see. So here we can see zero to see if the SSL and the SAL to bind SSL and SAL, and to see if the SSL connection is established. And then go to here. The process request, we can see there SSL read and SSL write. These two can to write and or write from read or write to or from the pipe. And this is a message we can see. This is something hello world. And as I mentioned, we present it shows in our terminal. And then we can see in the client side. So first is a verified callback, and there are two arguments. The first one is an integer, and the second one is a pointer. So this pointer is related to, we can see. So using the pointer, we can get the current certificate. And once this integer is equal 1, that means verification is passed. And if it's equal 0, that means failed. If it failed, it will try to print some errors. So first, it will print the, like we show in our terminal, we see some verification passed. And if it failed, it will give some error message. And then it's TLS client and TCP client. And another thing you need to mention is about the server. The reason why we need a TCP, because the TLS program is established based on the TCP program. So first we have to have a TCP created, and then we can run the TLS part, and then go back to client. So for the client part, this too is similar, just initialization. And also some verification use public and private key, our familiar things. And then this is set up TCP clients. We can see the hosting port and server address here. And to the main, this is our address, our host name. And so here's TLS initialization and create TCP connection and TLS handshake. So this is our code, and so we're using this TLS to implement the encryption part.
Hello, is there any question?
No, I thought it was actually pretty well explained. Good job. Understood what you put the VPN server on V. That's that's great.
We just call the name to change it to be the we haven't changed the name of the server. So
No, I know, but what I mean is you were
Yeah, we put
it to host V.
you ran TLS server on V, correct?
I mean the virtual machine's name, we didn't change the name, so it should be server, and then the other one is virtual, it's a host away. So
no, we put the TLS server on the host V.
Yeah, on V, on that third machine V. Yeah.
Yeah, correct.
Yeah. No, I get it. So no, good. I mean, good. So that built on the previous thing, the tunnel, and then great explanation on the code. So I think it's a great. Are there any questions from the audience? No questions. All right, great job, guys. Are you presenting something else? Sing.
We already present my our RCM in.
Okay. Already. All right. Good. Okay, so then the next group is Alex, Parker, and Brandon. Please go ahead and share your screen and begin.
Okay.
Are you guys there, Parker and Brandon?
Yeah, sorry. Can you see my screen now?
Yeah, I think he's bringing up the screen right now.
Hello?
Who's that? Parker?
Yeah, I'm Parker.
Is Brandon there?
Yeah, I'm here as well.
Okay.
Hello, can you guys see my screen now?
Yes.
Okay. I have 3 VMs right now, so I'm lagging a little bit. But I actually already pre-ran everything. I'm just going to explain it as I go from start to finish. So first I had to start the VPN server. On the VPN server VM, I did that. Where was it? I may have closed out the window. Let's see. Okay, so here's the VPN server. That's when I started the VPN server on VPN server VM. From there, I had to go start the VPN client, which is on this one.
Guys, are you there, Alex?
It may have crashed it.
Okay.
If you want, we could go over the RCM thing first. Well, he might need to reconnect if he's not there. Not sure.
Okay. Yeah, go ahead, guys.
Okay, I'm gonna have to share my screen. Let's see here. Oh, it says I can't start while he's sharing.
Yeah,
Oh, there it goes. Okay.
there we go.
Let's see here. Okay, can you see my screen?
Yes, I can see it now.
Okay. All right, like I said, group members are Brandon Alder, me, and Alex Gutierrez. And we decided to do ours on a fictional company, which is Dunder Mifflin Paper Company from the show The Office.
Mhm.
If you don't know anything about The Office, they're a paper company. They specialize in distribution of paper and providing customer service. So it's a paper company, and the IT requirements for it would be there's only around 25 to 50 employees. So we took that into consideration when setting up the network in our assessment for this particular company. And the type of technology that they use, they're just computers, printers, phones, some servers, and just some networking. They have, they have about 6 different departments: customer relations, marketing, information technology, human resources, accounting, and the warehouse. So we took that into consideration when setting up access to certain file servers and such. The scope of this project is to determine all the assets that are previously in place at the company and try to improve them as seen necessary. Putting in controls to attend to these threats. And you'll see the matrix that I have to explain some of these threats and what we decided to do for that. We created, like I said, a risk and control matrix as well as a network topography. Some of the business objectives of the company themselves are just to provide customer service to their clients, provide paper distribution, they want to expand their customer base as well as take into consideration any changes as paper companies are being phased out. Oops. Can you guys still hear me?
Yeah.
Okay, I thought I cut out for a second. Some of the business objectives on our end for the IT information systems would be that we would try to keep all the customers' information secure, as well as the employees, keeping the network secure so that attackers can't steal any information, any data from the employees or clients, having all the computers, phone systems, anything inside the business working properly would be what they would strive to keep. As for the assets, they have the physical location, obviously, is a big asset. They have the office and the warehouse, which handles the distribution of paper. The physical equipment that would be used is routers, servers. They have a phone system, obviously, like typical offices, and along with cabling. Some logical assets would be, vendors, customer data, employee data. Okay, now onto some of the risks that could happen here at this particular company. Malware could be a big one if antivirus software wasn't implemented. Things like Trojans, worms, and spam can easily distract a business, so focusing on that would be very important. Malicious activities such as DDoS, damage, data theft inside the company or outside the company needs to be taken into consideration. Some other risks, one of the possibly the biggest one could be social engineering. If someone got on the phone and was able to get information out of one of the employees, it could cause, damage to the company, whether they're releasing funding somewhere it shouldn't go or, private information. So that's something to consider. Another thing we consider a risk is out-of-date software. Any technology that's out of date, they're using, legacy software, which would stop being supported. You want to make sure that they're up to date as time goes on, because if they stop supporting, if a company stops supporting the software that they provided, and Dunder Mifflin happens to be using that, they could run into problems of being able to access it. And so it's important that software is up to date as well as hardware, so that they can increase efficiency and make it, things work as quickly as possible. And obviously there's physical threats to every business. So things like natural disasters such as, fires, floods, and heat. And so we've taken into, consideration of having redundancy of data backups and such for things like that. Here's the actual risk and control matrix that we've put together. If you can look on the right side, we put a list of risk priority. It goes by severity of damage, probability, what assets are potentially damaged through this particular threat, and whatever controls we've decided to put in place to prevent this threat. So, for example, the number one threat we decided was social engineering, because it causes severe damage. It has a potential to cause severe damage to a company through data or loss of money or anything like that. And the probability could be severe because as long as if you have employees that come in that aren't trained on this particular subject, it could be hard to identify when someone is trying to, it could be difficult to identify when someone is not the person that they say they are and potentially give out information that they shouldn't. Some of the assets that would be hurt obviously is the customer data, the employee data, physical equipment, if they decide to get tricked into, possibly putting some other spyware, ransomware on the computer. It could possibly hurt the equipment as well as other assets. And like I said, the most important thing for this would be just to train the employees to identify when something like this may occur. And I won't go through every one of these, but another one would be, like malware, DDoS, or malware would be, worm, flood, things like that. So for example, worm would be a severe attack. However, we have it at a medium probability of occurring just due to the controls we have in place, which would be antivirus software. You'd have a firewall that could detect. We could also implement an intrusion detection system that would have the potential to detect something like that. If we look at the number 16 here, risk priority 16, we have hardware theft. This is kind of an interesting one because it has a severe damage, but it also has a low probability of occurring. So for that, the asset that would obviously be hurt would be the equipment itself, but it's easily avoidable because physical barriers such as locks or security cameras, security guards would be in place, as well as only giving authorization to certain employees, like only authorized employees would have keys to server rooms and anything like that. So some of the main risks, like I mentioned, the majority of the risks on that chart, you can see a lot of them have severe consequences, but the main thing to look at is the probability, because this is what you can control here. You can't really control the damage, but you can control the probability of it occurring through, these sort of countermeasures that you could put into place. I would say improper configuration could be one of the biggest issues. Out-of-date software, like I mentioned earlier, can become a big issue if it overlooked. It can really hurt a company. Spam, phishing has a higher probability. Training your employees is important. Some of the controls, like I mentioned, a network, or just general network access control, giving specific permissions to employees inside of their departments would be important so that they don't accidentally delete files from other departments, folders. Possibly is important to control our files. Even if it's accidental, it's important that each file system is broken down into each department. As for the network, implementing port policies through the use of ACL rules would help negate some of the attacks that could possibly come through. The use of antivirus software helps with a lot of detecting things like web browsing activity. It's not so much a problem anymore, but I guess at the time of the recording of the show, it would be a problem. Like I said, physical barriers such as keys and locks would also help with the physical damage, or if the equipment would be stolen. So here we decided to include the floor plan of what it would look like, this particular business. You can see we decided to show this because it was particularly a smaller business. And so you have to take that into consideration when building a risk assessment for an analysis of a business, whether it's a big business or a small business. What you're going to do depending on that is going to vary. So you can see it's not a very big business. I think it's around 15 employees in this particular branch. The network diagram for this is fairly simple. You can see PCs are connected through a switch, which is then directed to a router, which is then goes to the main server. In conclusion, it's important to create a risk control matrix because it allows a company or an outsider to see vulnerabilities within the business and helps you manage these risks and treat them accordingly. It's harder to see them if you don't lay it all out. And so taking the time to do that helps the company in the long run. Yeah, and so Dunder, Mifflin Paper Company will hopefully be safer and a more efficient business with the help of this. Any questions?
Great job. Very interesting. Very good with the, the office theme.
Yeah, we decided to try and make it a little fun.
Yeah, no, it's actually, it's a good size, right? 15 people, kind of, simple.
Yeah.
They're just very simple stuff. It's great. It's actually
Okay.
good. Are there any, I saw your risk and control matrix, so that was pretty clear. Oh, nice. Are there any questions from the audience for this group?
On the matrix, you got NACs there. Were you referring to the network access controls?
NAC, yeah,
Yeah.
network access controls. Oops.
All right, any other questions, guys? All right, so great job. Are you ready to present VPN?
Yeah, I think I am this time. I actually presented the whole thing before I got a text message saying I was disconnected, so I'm not sure how much of that you got.
Okay, that's.
So I can start just from the beginning again.
Yes, go ahead, please.
Okay, I'm gonna start sharing a screen. Okay, so just to restart, I started the VPN server on my VPN VM, and you can see that on this window here. Once I started the server, I had to start the VPN client on the appropriate VM. You can see that on this side. And then you can see that I did receive a packet once I did connect. And then I got the confirmation I did connect back on the VPN VM, where it says connected with the client, hello. From there, it actually does give me the new tunnel interface. I had to set up with sudo ifconfig. And I believe I did that over here somewhere. If not, I can just rerun the command to see ifconfig -a. And then you can see that it did get configured over here. Once I did that, I had to start the TOS server on the VPN server. Where was that one? Here were my routes for the tunnel, by the way. Where's the server? I think I may have lost that command once I did ifconfig too many times, but I did start the server portion of TOS on the VPN server VM. Once I started that, I went over to my VPN client, started the TOS on this window over here, and you can see that I did get the confirmation by receiving the appropriate HTML text with the hello world. And then, yeah, I think my other information, my confirmations from the tunnels did get erased with the configuration commands. But yeah, this does show that I did get connected there. SSL connection is successful, and it was connected with the AES encryption 256. And I think that is it. I know I should have started Wireshark beforehand as well. If I would have received information saying client hello and server hello messages, followed by the appropriate client key exchange.
If you run it now, it won't work. If you like kill that client and start it again, it'll.
The
The
VPN client?
part. Just the VPN part, yeah.
Yeah, I can
So
restart it.
don't restart the machine. That's not. That's
Oh, just okay. Just exit out.
No. I just mean like that command in the terminal where you VPN client command, right? That's all I mean. Just
So
running it again.
Okay, so just
on your VPN client, you have a terminal, right, where you ran the command TLS client VPN labs.
Yes.
So
you over here.
Yeah, you could run that, right? And
oh yeah, rerun it.
Uh-huh.
Yep, running.
Okay. All right. Good. Are there any questions for this group, guys? Any questions? All right, so it works. Is there anything else you'd like to demo?
No, I think that's about it.
You guys are done. All right, great. Great job, guys. Thank you very much.
Thank you.
Next? I guess Susanna's group and Trevor? No, hold on. It's
I think
Trevor.
me, Trevor, and Evan
Yeah.
are ready.
Trevor, Neil,
Okay.
Evan.
yeah, go ahead.
Evan's got the presentation.
And he is not available right now, you said.
No, he's here.
Oh, I'm here. Sorry.
But someone else had said they had power hours. Okay, go ahead then.
Okay.
So just let's see who this is. Neil, oh, there you go. Thank you.
Okay, you can see my screen okay?
Yes.
Dan.
All right. So this is our risk assessment for the Bank of ITS 454. Just a little bit about the bank.
This is going to be a much more complex thing, right? You went with a bank.
I'm sorry, what was that?
This will be more complex since you've gone with a bank. A bank is more serious IT infrastructure.
Yeah, it's a little bit more involved. There's a lot more security controls that we had.
Great, go ahead. Sorry. Go ahead.
Oh, sorry. So we have several branches located in Northwest Indiana. We're more of a regional bank out here. We provide a wide range of banking services to both businesses and individuals. Some of our departments, we have HR, and then we have an extensive list of banking services such as retail, commercial, loan servicing, online wealth management, e-banking, investments, and we have about 200 employees across all of our branches. Just a few of our objectives here. We're providing 24/7 access to banking accounts, statements, and features on those accounts. And features meaning like checking FICO scores, managing investment portfolios, and that kind of stuff. And some of the accounts that you can check are savings, credit cards, etc. Also, we provide an online platform for our customers to invest. Additionally, there's investment options and retirement plans for people to pick from. And also, we provide access for small business loans, mortgages, refinancing, auto loans, and a bunch of other loans as well. Our main focus on the requirements were to have access to these features 24/7 in a secure manner. Now, as a bank, we have a little bit different list of assets. For instance, you can see at the bottom, loans are where banks make most of their money. And so that's one of our bigger loans, and cash on hand, that's also a loan. But there's a lot of IT infrastructure and hardware that the bank owns. So there's computers, routers, switches, servers. We have isolated servers handling sensitive data. And then, of course, you have things like ATMs, employees, physical structures, furniture, equipment, and then the network. Cool. So here are some of our network threats that we have. There's a large list of a bunch of different ones, but some of the big ones would be like malware, ransomware, spam, unauthorized access, denial of service, which is a big one, ATM card skimmers, and viruses and Trojans. All those can like bring down a lot of your uptime for what you need. Next slide. So some of the controls that we have for network threats include firewalls, IDS, IPS, antivirus software, ACLs, complex passwords, and data encryption. The data encryption is big because if they can get through the firewalls, then at least they can't see what's going in and out. And then here's our risk matrix. Some of the big ones like viruses and spam can also be like severe. Like spam has a high probability, but it's not as big as a threat because you can work your way around it a little bit. Whereas if you have a virus, it's a higher probability or higher damage because it can completely change bank accounts and get information that you don't want other people getting, along with denial of service is another big one that gets rid of your data, your money, and your services that you want to provide. And on the right-hand side, a lot of the controls that we have are using stored procedures, updating the software, firewalls, again, that's mainly for a lot of the network threats, and IDS and IPS security measures. Now, once we were doing the assessment, we also realized that there are a bunch of miscellaneous threats that didn't necessarily pertain to the network infrastructure. And some of those were things like a natural disaster, earthquakes, tornadoes, not necessarily here, tsunamis and hurricanes, obviously, but other areas can get those. There's floods, fires, excess heat, and in that, we meant more so in the server room area. If that gets out of temperature, then you can start running into issues with services. And of course, power outages, malicious devices, improper data handling, physical theft, and then insider threat. With insider threat, we meant more like a bad actor. So for instance, I think it was a couple years ago that Bank of America or Capital One had someone who had one of the biggest breaches in their company, and there were millions of records that got affected. And that was something that a lot of businesses face. So here's some of the controls that we had to mitigate these threats. So for a natural disaster, a preparedness plan would definitely help you know who to contact, where to go, where to have employees go, and also where your employees or who your employees can contact. Then, of course, temperature and humidity controlled server rooms, off-site backups, insurance for any loss of property, training employees on safe practices, on data handling, and also updating them on policies. And then lastly, physical locks, keycard access to sensitive areas like server rooms and security cameras. Here is the matrix for the miscellaneous threats. For the most part, almost all of these you can see here are pretty severe. For instance, if a building caught fire and everything burned down, that's pretty bad. You got to start all the way over. But the probability of that is actually pretty low. And there's things like the temperature controlled rooms, sprinklers, fire extinguishers, and insurance to help mitigate any potential loss of that. And additionally, almost all of these affect data, hardware, and physical structure, but also money. Since we're a bank, if anything were to be affected, that basically affects the bottom line. So money is definitely going to be lost if any of these things happen. And here's kind of like a model of our network design. It's kind of big, but I'll just try to explain it as best as I can. So for example, the left branch would be like one building. The one on the bottom is like your backup site. And then the right one would be like where all your ATMs would be that need to like remotely do everything. So on the left-hand side, you have like physical measures, which are your web cameras and your RFID readers to prevent people from getting in that you don't want. And then you also have your security people on that side. You have your security server and your web server over there.
And then beyond that, there's a backup server on site for just to have a duplicate, so that if something happens to the main information, you always have a backup, and that's hidden behind another firewall to prevent more people from being able to access that. And then on the lower right, that section, you have all the people's computers that are all connected to a switch that connects into the router, which then connects into another firewall. And then that goes out to a public network. So for the bottom side, you have one offsite firewall, one router, and one switch. And then you have one computer and one server. You're trying to minimize as much access to there as possible. You don't want anyone getting to your backups. It might even be better just to have someone physically back it up rather than have it connected to a network. And then on the right-hand side, you have your ATMs, so that those would all be guarded by a firewall. You'd have your router, and then a switch could connect multiple ATMs if there were multiple ATMs on one site.
All right. Any questions for us?
Very interesting. Great job. Can you go back to that diagram, please?
Yeah.
Was that just one? Did you say this was just one building?
Yeah, so that would be for like one building. So the left would be like the bank. The bottom is like the offsite backup records, and then the right would be like where your ATMs would be.
Okay, and then what is, so that midpoint that where it says cloud point public network?
That's just a public network. So like,
are they going through the network, or do you mean that that's where they connect to the ISP? Because it's the same building, if I understood correctly.
no, so these are this would be like 3 different buildings. So like
okay. So
they would go across a network.
Got it. Okay.
Mm-hmm.
So somebody, okay. Somebody wants to check the ATMs from site 1, right? That's what, okay.
Mm-hmm.
They have to go through a public network.
Mm-hmm.
Okay. Definitely there, some kind of encryption.
Yeah.
Okay. That's what that means. Okay. So let's see. Yeah, great. All right. So that was the only thing I wasn't too clear on.
Mm-hmm.
Very interesting. All right. Good job. Are there any questions from the audience, guys? No questions? Everything's clear? All right, great job, guys. Very interesting. Thank you for doing, bank seems more challenging to think about.
Thank you.
Thank you.
Are you doing anything else?
Oh no, we did VPN on Tuesday.
Okay, you already presented. Okay,
Yeah.
Great. Okay, so if they presented, who's next?
We are.
Okay, go ahead.
Kyle, do you want to do the VPN first, or do we want to do the other project first?
I'm ready to do the VPN part. I have it all up.
Okay, you go ahead then.
So who's in your group, guys?
Hank, Susanna, and Kyle.
Okay, thanks.
Okay, Spidey, you can't play with my computer.
Oh, but why not, he says.
Yes.
Anyway, so I have already set up the tunnel on both the server and client. I just have the 2 VMs. I didn't bother doing anything with Ph.D. just for simplicity. So the tunnel's already set up, and actually I have a telnet connection between the client and the server right now. You can see that packet here. I did an LS, and you can see that it's kind of hard to see, but that says like desktop music and something like that. It's a partial packet, but the reason why I show that is so that later when I encrypt the tunnel, you can actually see that it was truly encrypted. The other thing to note is that in Wireshark, that same packet, the source is 53.1, which is the server, because the client is telnetted into the server. And then the destination is the client address, because the server has to send its information back to the client. So that's it as far as that part is concerned. So next, I want to do the TLS server part. I'm actually going to exit this because that's not needed anymore. Gonna go over here, although probably should be noted that in order for the Wireshark to capture the TLS properly, you have to be sure that you go into preferences, protocols, and then HTTP. Actually, I already passed it. Let's remember the alphabet. And you need to make sure that this port is declared here, otherwise it will not grab it correctly. So that is declared, so that won't be an issue. And then we're going to actually restart that. First, I need to start the server. So I will start the server there. And actually, I already have in the open a new window. I already have in the etc says host of the client the Tune 0 interface IP address for the VPNLabserver.com, so that it has no choice but to use the Tune interface. Oops, I did not mean to have that be brought up. Okay, next we are going to connect to this. Oh, running the TLS server on the client, that's not going to help. That would explain that. I'm like, why isn't it working? That would be why.
Might make it a little easy that way.
Segmentation fault. Why are you having a segmentation fault? It might be the www dot part. There we go. That's better. You can see it worked that time. You have to do the www dot part, otherwise it won't work. Forgot that. But yeah, you got the VPN Lab server down here. You've got the host name mismatch because it's looking for vpnlabserver.com, but I put in www.vpnlabserver.com. And it says it passed, and it says it expired, and it says it's successful, and that it's using this version of AES 256 to do what it needs to. And you can see it worked over here. And then as far as the Wireshark is concerned, let's actually make this bigger. You have the TLS key exchange here. You have some application data here. You have this encrypted alert. I think though, well, actually, I think that's it. Because after you run that, that's just it, I think. I think I just did it. I think that's all there is to this. Unless I'm mistaken, but I think that's it.
No, you're right. So good job.
All right, now it's on to the RCM, so I'll stop.
Okay.
Sure.
Same group.
Do you want me to share mine, Tink, or?
I actually made some updates to it, so if you want, I can share mine.
Okay.
Okay, let me go to the beginning.
For our project, we decided to go with a small company, fictional company, but not so fictional because Tink used to work there.
Yeah, the fictional company is based on a home healthcare agency that I was both nurse manager and IT/HIPAA person for. A lot of hats. Okay.
Go ahead.
It is located in Griffith, Indiana, and we care we offer in-home health care for our patients, our customers, including skilled nursing, companion care, homemaker services, physical and occupational therapy, and certified nursing assistant services. Some of the components in our infrastructure that we need to guard against any physical damages are servers for storage, which would have like the electronic medical records, accounting, payroll records, network printers, scanners, copiers, desktops, hosts. We just have one router and one switch, internet connection, and our cabling. The departments for this small organization is nursing, accounting, IT, human resources, and payroll. Our business objectives are to create a safe and caring environment for our clients, provide care for clients and their loved ones, and of course, it all have to be within the federal guidelines for medical practice protocols. Some of our assets are like client data. Our logical assets are client data, insurance data, employee data, company proprietary data. Physical assets are like our routers, PCs, switches, one switch, the building, printer, server, medical supplies. Some of the potential risks that we would be facing, it's like viruses, as far as like our network would be spyware, ransomware, malware, ARP spoofing, data loss, or some unintentional bad configurations that we could have, social engineering attacks, elevated privileges.
Yes.
Okay. For our assets, as we mentioned before, we have our main server, our computers, our router. Some of the threats would be power outages, data corruption, viruses, fire theft. One of the more severe ones would be a power outage. Since our company is pretty small, some of the controls that we have is like weekly backups. We have a server rack, key access to just 2 people that would have access to a particular room, a security alarm. And for our router, the same thing. We have a built-in firewall mechanism in our server rack, which is what really guards all of our servers and our router and switch. Some of the probabilities would be like the most likely would be having backups so we don't lose any of our data, and to protect all our company's assets, all of clients' information and employees' information. We also have, as one of our controls, the login authentication system for everyone that would access any information they want to access, like the clients and employees.
Yeah, there was a 2-factor authentication system in place for anybody who has access to the electronic medical records.
Some of the this is continued here as far as what we have. Our assets, our switch, our printer, our medical supply closet, filing cabinet. Threats would also be like power outage, theft, fire. Some of the existing controls, as we mentioned before, we have our server rack, security alarm. Our door, actually, our server would be in a separate room where nobody has access to it except for like 2 people that have keys for that particular room. We also have, in case of a fire, we have a fire extinguisher, smoke detectors, security alarm. And that's pretty much it because our store is pretty small.
Yep. And then the physical building is roughly this.
Can you go back one slide or two?
Sure. Oh, wait. Here, hold on.
The one that where you hold the electronic medical records for the server. You just go back to that. I think it was in your risk register, the first slide. Yeah, the one more. Yeah.
Here we go.
Okay, so this is that main servers and computers. That's where you store your electronic medical record software.
Yeah,
That's correct.
All the EMR is on the main server. It's a small company, so there's only the one server that handles everything pretty
Is
much.
that EMR online somehow, or is it just a local program where the data is stored on that?
There's a local copy and then there's a cloud copy.
Okay, and you have data in both places?
The part of the automatic backup is that everything syncs nightly to the cloud. The cloud is controlled by the provider of the electronic medical record software.
Okay, so it's more than a program, it's a service for electronic
Yeah.
records that you're paying for.
Yeah.
Okay.
Yeah, and like I said, it's got a local copy that's stored on
Is
the
that a
computers that need
requirement
it.
of HIPAA that you have to use that provider or one of several providers that they specify for EMR?
Yeah, there are certain licensed providers for electronic medical records.
Mm-hmm. And then you have to use
because they have to have certain security protocols in place.
Right, and that's a HIPAA requirement.
That's a HIPAA requirement, and it's also a Medicare requirement.
Got it. Okay. All right, go ahead, guys. Thanks.
No problem. Okay, back to the next screen.
Back to the bottom, yeah, to the bottom. You have to scroll down. Yeah, we already covered this slide, I think.
Okay.
And that one also.
Yeah. Yeah, HIPAA also requires, and the state requires, that there's a hard copy of each patient's records kept on site. So one of the big other risks is that filing cabinet, which is locked in a separate locked room in a fireproof cabinet. Because when state inspectors come, they don't want to look at the medical records online. They want to pull out the hard physical copy. Plus, it's a final safety protocol against loss. If all the power was out and things were going to be down and there was no internet, we would still have hard copies of patient records to go to for all of their information. Okay, and this is a map showing there's the server rooms kind of in the back of the building with no access to the outside immediately available. And most of the equipment's stored in there. The only other equipment, as far as electronic equipment, is the PCs that are in the different offices. This is a little bit better. This is a logical diagram of it. The server, the router, and the switch, and the connector out to the cloud that's provided by the EMR service are all in the server closet. And then the other things are just the PC hosts that are connected into this network, and then there's a networked printer, scanner, copier, fax in the reception area.
As we had mentioned before, we have our countermeasures here, like for our server and our computers. There's a high risk of if we lose power as everybody's trying to access our information, like employees. Or so what we have is one of the controls is an uninterrupted power supply and a backup generator to keep those going. The router, which runs a firewall, could also be down. And so we also have like an external outside router, such as an ASA, for it to guard all our assets, especially like data for our customers and all the clients and for employees. Okay, also we have, as one of our assets is our medical records, as the server could be hacked, which is moderate risk. And for that, we have a two-factor authentication login system. And also if a storm could cause a spark or anything happen that could catch on fire, we have our fire suppression system as a control for that.
And that's it.
And that's pretty much it.
Did you have Active Directory services in there for login, or was it just like local login on the computers?
It was local login on the computer with
two-factor.
yeah, well, the EMR software was a two-factor. Local login for the PCs, we just had a rather robust password protocol.
Okay. All right. Interesting. Are there any questions from the audience, guys? All right, great job. Very interesting. Thank you. All right, who is next?
It'd be me and Nathaniel.
Okay.
I'll start with the risk analysis.
Okay, yeah, sure.
1 second. All right. Did you see this one coming?
Tesla?
Yeah, so
okay.
We did ours on the showroom and service center of a Tesla. I kind of just thought about cars, and that was my first thought is Tesla, and it's a simpler service room and show.
Send this to Elon Musk. Maybe you'll get a job over there.
I don't know if I want a job over there. I've heard it's very stressful.
Okay. Yeah.
The project scope is what's the business objective, what are data assets, possible threats, and the risk assessment, and the matrix and the network topography. So we'll go for the objective for the showroom. That's basically to provide customers with information about the cars and show the cars to the customers and the benefits of owning one, and increase the awareness of Tesla and persuade more people into buying the cars. But they don't really sell the cars. They kind of just give you a computer to buy it yourself. So there's no really selling. The business objective for the service center is obviously to provide customers with hassle-free repairs, make it as cheap as possible, and fix it as quickly as possible because obviously everyone wants their car. Satisfy the requirements and give an accurate time frame, which they update the app with the time frame and everything for the customers. Usually they also give you a loaner and expand and update the service centers when more is needed. Then the assets would be the buildings and the parking lot, the physical equipment like the network equipment, computers, smartphones, printers, cars. Logical would be the employee data, car data, customer data, credit card transactions for repairs. And the risks would still be the same as mostly every business, the malware, network attacks, social engineering, outdated software, natural disaster, hardware theft. I would say social engineering and outdated software are the biggest ones. And if you look at the control matrix, most of them I put as the probability is low because as you'll see on my network topography, it is a private cloud for them. So for the hacker or whoever is trying to infiltrate, they'll have to go through one of the employees' computers because I would set the MAC security on the Cisco devices to if the MAC address doesn't line up, they can't really connect to the servers and do anything. And you would have the separate VLANs for each for the customers and for the employees. So the customers also would just have a guest Wi-Fi, which wouldn't really have access to anything that the employees have access to. But I would think that the most severe would be outdated software because that there's exploits, and hardware theft is also a big one. I don't know how you're going to drive off with a car, but I guess you could. Data theft is also a problem if an employee picks up a USB off the ground or something like that and plugs it in, trying to find out whose it is. Well, there goes everything. Social engineering is also a problem. Same thing. Employee not having a good password, not having good credentials. Internet misuse, I also thought was a big one. In case an employee or a customer does anything on the internet and Tesla could be liable. So you'd have to have some kind of ACLs to limit that. And poor connectivity could be a big one too, because if the employees can't reach the database, that's a problem. Like I said, the main risk I would say is probably social engineering and phishing, because if an employee clicks on a link and gets their password stolen or something like that, that would actually be a problem as well. The controls, NAC, obviously, the ACLs to prevent websites, stuff like that. Deep freeze you could set on the computer. Besides their H drive would be their network drive. It would wipe the computers every day, and redundancy for the network. If one thing goes down, the whole network doesn't collapse. And physical security like cameras, locks, stuff like that. Make sure updating every software when possible and maintenance. And I would also require training for the employees to not fall into social engineering and have those kind of problems. Separate VLANs, like I said, firewall. And I would also not give any of the employees, unless they really need it, USB access to their computer, like flash drive access, because that's mostly where the problems can come in, virus related. And then if you look at the network topology, it's a private network. So you would have redundancy on all the switches and on all the routers. And you would obviously have the access points that would connect to the guest smartphones or the computers in the service room or the showroom, and the printer. And I'm guessing they would also have some tablets, but you would also have redundancy on the server side. So you would have multiple servers, redundant servers, because this is what would store like their emails, their customer information that came in and stuff like that. That's highly important. And this would be on a private network. So there's not much of a risk for hacking unless someone can get in to that private network. And that's pretty much it.
Okay, so here in this diagram, so that the Tesla data center, that's Tesla, right? That's the Tesla company.
No, this would still be the data center just for the service.
Oh, it's still, okay.
It's a private, completely private network right
What
here.
is that for then? Because you place the orders on Tesla, right?
Right. I'm doing the private data center just more so for like the employee emails and for
I see. Okay, so this,
their information. I didn't even put the actual Tesla data center because that would include a lot of firewalls and whatnot.
so you have a data center for the company.
Correct.
Okay, and then on the other side is a showroom. So this basically, like if you had two showrooms in two cities, they could both connect to this data center.
You would probably have separate ones because each service center only keeps track of the customers that go there. So you don't really need to know the servers on the other data center or on the other site.
But that's the cloud, that little cloud, that just means the internet.
That just means, yeah, the private. Yeah, exactly.
The internet. Okay. And then the service center, I think, that's where they buy a lot of inventory, maintenance, and all of that, right? Work order. Okay, so is that the system provided by Tesla as well?
No, I just made this up.
Okay, all right. No, I'm just saying, would that be Tesla also, or is it a local program that they use?
Yeah, it's still Tesla.
Okay. All right, very interesting. Are there any questions, guys, for this group? No questions? All right, so this is Nathaniel, Sokolowski, and Paulo, right?
Yep.
Did you guys present at the RCM right now? Have you done the VPN?
No, we're doing that right now too.
Oh, okay, go ahead.
Yep, Nathaniel will do that one.
Alrighty. I'm hoping everything held up because I had all the VMs running. I just lost power about a half hour ago. Or just came back about a half hour ago. So I'm hoping this didn't really kill any of the VMs. But I tested it. Everything seems to be working all right. Can you guys see my screen?
Yes.
Alrighty. So I just have like the VPN already running and whatnot. But there is the server, the TLS server, have that booted. And then on the client, we have the SSL connection was successful, and then it's using the encryption right here. And then we have it displaying what the HTML would display with the hello world and everything. And then I'm not sure for everything else how it's supposed to work. So I don't have this connected to the internet at all. It's just this local network. I tried to test it to see if it would display the HTML page, but it doesn't necessarily, but it shows that it does work, that it is connecting still to that server and whatnot. And then I was still messing with a few things because I don't think this is, I'm missing a few things because I was trying to get the TSL to appear on here, but I wasn't 100% sure how to do that. I think it's based on the port that I'm using because I'm using 4433, which I think Wireshark doesn't pick that up for TSL. It only picked up on 443 or 433. And then just a few edits in the code and whatnot. Oh, one thing I will mention that I was noticing groups were having that was a little different than us with the right here, they were getting like successful and unsuccessful certification attempts. I'm not sure how other teams got about getting around that and whatnot, but when I noticed for our certs, they were expired. I don't know if it was this one around the server. Yeah. So ours were showing, oh, it's a server one that was expired. Yeah. So ours are showing they expired last year. And I ended up changing the date on the VMs. I'm not sure how we're supposed to have gone about that or how other teams got about that, but it stopped us from getting all those other messages too.
Right, that makes sense. So it's you know, you have a certificate that expires in 2019. The machine checks its date. It's before, but it's okay with it.
Yeah, because I know other teams were getting it, whereas like saying that it was unsuccessful and whatnot, and then I was talking to another group and they were mentioning that as well, how theirs was failing, but they just kept working with it and eventually got it. So I wasn't sure necessarily how to get around that.
Okay.
But yeah, got the TSL and everything working with the VPN.
Okay. Good. So when you run this, so you have the TLS server and VPNs in server VPN. Is that where it's running?
Yeah.
Oh, okay. And then you have TLS client in client VPN.
Yes. I just use the same VMs from the VPN lab.
Right, of the tunneling part.
Yep.
All right, great. Yeah. Yeah.
And this shows that this is on the server side, shows that the connection was established like it did over here on the client side.
Okay. All right, looks good. Guys, are there any questions for this group?
Were you going to show the code or something?
I show a little bit of the code. That was on here. In terms of the code, changing it, there wasn't a whole lot that I changed to get this all to work. Is mostly like the port and everything, which like I said, I use port 443 on the client and the server to get them to connect. But yeah.
What happens if you go back over to the client and go back to the code and on, let's see here. Scroll up a little bit. I think it's right there where it's SSL underscore CTX, SSL verified pure null. Is that where I'm thinking it is? I hate not having the line numbers.
Yeah, I just double clicked it for gedit instead of.
Yeah, subline or whatever. Scroll on up.
I don't know why it's not letting me. Oh, there it goes.
There we go. Yeah, copy that verify underscore callback on the integer, fourth, fifth line and sixth line up from the top.
This one?
You just see verify callback. Okay, copy that. And then scroll back down to that one right there. And replace the null there, the first null, with that. Paste that in there. And then save that, recompile, and then run your client.
Okay.
Just make. That works too. And then run your, yeah. Okay, so there, verification pass, verification, that's cool. That's what I wanted to see. Thank you.
Mhm.
All right, so great, interesting. Okay, so are there any questions for this group? Okay, no questions. So thank you very much, guys. Great job. Do we have any groups left that still haven't presented at this time? No? Okay, so let me just give one look here. Let's see. So I believe pretty much everyone has presented. All right, great job, guys. Thank you very much. So we're done for today. We're actually done with the semester at this point, right? And all we have left is the exam on Tuesday. So look for that. If you have any questions about anything, please email me. Make sure you email me, and have submitted everything before the day of the final, okay? Because once I get to a point where I can do the calculations on your grades, I'm gonna post right away, okay? So, you wanna definitely get to me before I posted grades to the system. Okay, so otherwise, great job. Thank you very much. I really enjoyed the class, even though we had to make some changes mid-semester. It's fun to have you guys. So I would, we're gonna stop here. I'll see you. I won't see you again, but you have your final on Tuesday, and then I wish you a very good summer, and hopefully we will be back with some of you. I know some of you are graduating, so congratulations to those of you that are graduating. Those of you that haven't, hopefully we'll be back on campus in the fall. Okay? All right, so we'll stop here for today.
Thanks for everything, Professor.
Thank you, Professor.
Sure.